Hey there, YouTube. Well, it's a little late. I can't sleep. I'm still sick. So, my sickness is to your benefit, and I'm going to give you another video tonight. I figure what I do here is give you a simple little demonstration of how EIGRP works. EIGRP is one of the many routing protocols that is used in the corporate world. It's actually a fairly easy and pretty robust routing protocol. Basically what it allows you to do is you can take a couple networks that are typically not able to talk to each other. This is kind of a simple little topology I put together, and this is a program called Cisco's Packet Tracer. Some of you that may have gone through the CCNA Net Academy may already have this. If not, I should be able to get it for free if you're part of the Net Academy. If you're not part of the Net Academy, you're doing some self-study. Maybe you might know some networking friends that already have this. If not, you didn't hear it from me, but you can get it from it kind of rhymes with the dark side of the internet. So you should be able to get that. It's an okay program. It's what we call an emulator instead of a simulator. It doesn't have all of the commands on it that a full-out Cisco iOS would have, which is a lot of the benefits for a simulator, something like GNS3 that runs actual iOS software. So it would be just like if you were running a real router or a real switch, versus something like this. It kind of just emulates what would theoretically happen if you ran a ping or if you had this command put in. So it's works okay to an extent if you don't have money to buy real equipment, or if you can't get GNS3 to work or something like that. It does okay for CCNA stuff. It's fine. But so the basic topology I'm kind of doing here is, on this side we have a 192.168.2.0 network /24. As you can see here, I have my computer here set to 192.168.2.254. The gateway is 2.1, and then we have a network set up in between these two routers, which is a 3 dot. So 3.1 on this side and a 3.2 on this side. And then over here we have our other user network, a 192.168.1.0 network. Now what we're going to do is we're going to try to use EIGRP to get the 1.0 and the 2.0 to talk to each other. As it sits right now, these two cannot talk to each other. We can do a quick ping to demonstrate. As you see, I've already been kind of playing around with it a little bit. So it can ping its gateway. So that is good. And it can ping the outside interface, which was the 3.1. Oh, now if I type ping. And that's fine. Beyond that, it cannot see anything past that outside interface. So if we try to do 3.2, which is the interface on this side of the network, we've got nothing. And of course, it would be like that for the rest of the way as well, the 2 dot. So what we're going to do is we will establish EIGRP on both of these routers. We'll get them to talk to each other and share their router information about all the networks that are connected directly to them. So the 1 dot network will learn about this 2 dot network on the other side. What we'll start with first is this first router. And what we'll do is we'll go into config T, and the command for this is pretty simple. It's just router EIGRP, and then you have to give it a number. and go from 1 to 65, 535. I like to stick with 80. Just a nice round number. So now EIGRP is up on this router. Pretty simple, right? So now what we have to do is we have to specify what networks we want to be part of EIGRP and what networks will share information out to the other, what we call adjacent routers. And we'll figure that out in a second as far as what an adjacent router is when I get the other one configured. So what we want to do is we want to get this 1.0 network and this 3.0 network to talk to the other side of the network over here. So we'll type in network 192.168.1.0, and this uses wildcard bits. So instead of doing 255, 255, 255.0, you're going to do 0.0.0.255. And then we will do network 192.168.3.0. And that's pretty much all there is for that one. Except, an old trick of the trade here, EIGRP sends out periodic routing updates. It's called a hello timer that sends out. Basically just make sure that everything's up and running. That's how it knows that if a link goes down, by sending out these hello packets. To help with the network traffic, you don't want those hello packets to be going out your network here where all your user computers are. That's just a waste because there's no other routers out here that's sharing any routing information. So what we can do is, it's called a passive interface. What a passive interface does is it blocks any of these hello packets from being sent on a specific interface. So we'll do passive interface, and we specify what interface we want. And that is interface FA01. That's all there is to it. So that one is up now. So what we'll do is go over to our second router, and we're pretty much going to do the same thing. And keep in mind, remember when we set up EIGRP on this other router, we said router EIGRP 80. Make sure you use that exact same number on the other router, otherwise an adjacency will not form. They will not talk to each other, and then basically you got a moot point and you're never going to get any neighborships formed. They won't talk to each other, and these two networks will never see each other. So we'll do router EIGRP 80, and then we will do our network commands. So we want into network 192.168.2.0, and remember it's a wildcard, so 0.0.0.255. And then you want the other network 192.168.3.0. That'll come up. And as you can see here, we just got a message here. It says dual 5 neighbor change. EIGRP 80. Neighbor 192.168.3.1. Fast Ethernet is up. Neighborship adjacency. So what this is saying from this router is there is a neighborship formed with 192.168.3.1, which is this guy, so it sees this. So it's saying, hey, you're my neighbor now, so let's exchange some routing information. So now what it should see is all of the neighborships and networks that are on this other neighbor router. And what we forgot to do is put that passive interface on the same interface on this side, so those hello packets don't go out this side. So we'll do that real quick. Alright, so now we want to see what networks are showing up on this router. This is pretty simple. To look at the routing table, you do a show IP route. And what you see here is the routing table of all the routes that it knows about. And if you look at your codes up here, a C code, it means it's directly connected. So you have a 2.0 and a 3.0 saying it's directly connected. Here's a 3.0 directly connected, and a 2.0 is directly connected. Now if you look here at the top, this 1.0 just showed up, which is our network over here. And it is given a code of D, which is EIGRP. So it learned about this network via EIGRP. So this means that it should see each other now. And we'll jump over to this router. And as you see, it had the same message come up. And it says the neighbor 1.2.168.3.2, which is this guy, is formed an adjacency, and I see his routing updates. So I know about the 2. Network, hopefully. So we will look at the routing table and verify that. So we'll do a show IP route. And we pretty much have the same thing over here. We have a 1.0 network directly connected, which is this network. And we have a 3. Network, which is directly connected over here. And as you see, we have a 2. Network showing up as a D, so it's EIGRP. And that's the 2. Network, so that is this guy. So we have an adjacency, it's sharing routing updates. So let's see if we can ping the other network from the 1. Network. So we want to, first let's see if we can ping this 3.2 that we couldn't ping before. And as you see, now it is pinging because it knows about that network. Now let's try pinging that other computer that we couldn't ping before. And we're getting responses. So now we have a converged network. Both of our networks are able to talk to each other. They have learned their routing updates via EIGRP. And looks like everything is all happy on this end. So now let's try pinging the other end. There's actually the router interface over here. Let's try pinging the PC 254. And we're getting a response on that as well. So now everything is working. And in the case that EIGRP fails, it will give a message and say the neighborship has failed. So let's try to break this real quick. What we'll do is I'll actually just disconnect the link off of here. Not what I want to do. I'm trying to delete the cable. There we go. Alright, that's the message I was trying to get for you. So now it's saying that a neighbor changed. The 3.1 is down, and the holding time has expired. What the holding time means is that when a neighborship fails, it goes into a holding timer that holds that route for a specific amount of time, and then it'll actually flush it out of its routing table completely. So as you see, because it's lost that neighborship and the hold time has expired, it has now flushed that route out of the routing database. So now what we'll do, we'll put that link back in there. And we wait. Make sure I didn't booger it up when I accidentally deleted that router. It's there. Okay. And you can see now that that link is back up, we have the new adjacency. Show IP route. And our route's back in there. So you can see what would happen if this router happened to go down, or if the link even went down, since I did kill the link going across. So that's where you would actually need to have some good topology design skills and have some redundant links running across so they would all talk to each other in case one of the links happened to go bad, and kind of go from there. But this was just a little simple demonstration exactly how the EIGRP works and how they talk to each other. So this is a pretty robust routing protocol that you can use. I've actually seen this set up on some switches where you use some layer 3 switches and set up EIGRP on that, and have the two routers actually do nothing but handle the WAN traffic come into it. And then you have your two switches do all of your routing down here. And then you can kind of set that up as your kind of like a failover. If you had some redundant links, and my voice is really getting ready to go, I apologize. If you have two WAN circuits, like one here, this one's going to Verizon, this one's going to AT&T or Time Warner or Comcast, whoever you're on. You can have the EIGRP down here know about the routes that it needs to go to, and then if this link happens to fail, EIGRP will kick in and say, hey, this route is bad now. I know that this way there's another route to that same network, and we can switch everything over to that. So it'll actually kill the route that it knows about going this way, and it'll go to a secondary route out this way. So it uses kind of like a failover. So you can have two links, and in case your internet ever excuse me, ever happens to go down, then you have the secondary circuits able to kick in, and you can continue business as usual, even though your main primary circuit has gone down. So it's another cool little thing you can kind of do with it. Or you can actually just use HSRP or VRRP, stuff like that, instead. It's just kind of whatever flavor you decide to use. And hopefully this video has been insightful, educational, and maybe a little fun. If you can get a hold of this packet tracer, play around with it. Get you 20 routers on here and throw some EIGRP on there and see what happens. Play around with it. You can actually learn quite a bit about your routing loops if you don't exactly have the stuff set up correctly with your EIGRP, and you can watch all this stuff break and watch the routers light up, and yeah, just have some fun with it. So as always, please subscribe at the top, comment, like it, let me know if you have any questions, and have a good one.